Now in this video we are going to find out derivation of length contraction, because in the last video we have seen what is length contraction. So let us now derive mathematically how the length is getting contracted when it is seen from moving frame of reference. So here we have taken two frames. The one frame, which is a stationary frame, that is this one, we are calling as a S. Now we will take a rod which is placed along the x direction. So x1 and x2 are the end points of the rod, and as we know that generally by taking a difference in end point we find out the length of the rod. So this L is equal to x minus x1 is nothing but the length of the rod in stationary or rest frame. Now let us see what will be the length observed by the moving frame. So consider a moving frame S dash with a speed V along the right hand side. Now when we are seeing from the moving frame, the endpoints observed for this rod are x1 dash and x2 dash. By taking this difference, we will get the length of the rod in the moving frame, which we are calling as a L dash. So now we have the two length. One length is measured from rest frame and the one is measured from the moving frame. Let us find out the relation between them, and for that we are going to use the Lorentz transformation. In our one of the video of Lorentz transformation, we have seen the equations of Lorentz transformation, in which this is the one equation we are going to use, that is x dash is equal to x minus vt divided by under root 1 minus v square by c square, where v is the velocity of the frame with which it is moving, t is the time, and c is the speed of light. So let us find the relation between L and L dash, that is the length of the rod in rest frame and moving frame. So L dash is equal to x2 dash minus x1 dash. After substituting the Lorentz transformation coordinate system from one frame to the another frame, we will get this equation. That is, what is x2 dash? So by using this equation, the x2 dash will be x2 minus vt divided by root of 1 minus v square by c square minus x1 dash, that is x2 minus, oh sorry, this is not x2, this is supposed to be x1. Now it is correct. So x1 minus vt divided by root of 1 minus v square by c square. By taking the difference between them and solving the equation, we will get L dash is equal to x2 minus x1 divided by root of 1 minus v square by c square. Now already we know that x2 minus x1 is nothing but the length of the rod in the rest frame. So we will substitute that value in this equation. So we got a new equation in which we are getting a length contraction formula of the length of the rod, that is L dash is equal to L divided by root of 1 minus v square by c square. After simplifying, we can also write the same formula in this way. So now this is an equation, mathematical equation, that tells that the length of the rod is reduced by this much factor in the direction of motion when the rod is moving with some velocity, or maybe frame is moving with some velocity and it is seen to that rod. Now what is the meaning of the length is contracted along the direction of motion? So let us take example of this pin. Suppose this pin is moving along in this direction. So only the length, that is this much, will be get contracted because pin is moving in this direction, not this height means now here the diameter of the pin is coming, that will not decrease, that will remain as it is, because pin is not moving upward or downward, pin is moving right hand side. So only along the length, only along this motion the length will decrease. That is the meaning of the length of the rod is reduced along the direction of motion. So let us discuss the two cases when v, that is a velocity of frame, you can say, or velocity of that pen or maybe rod, is very small as compared to the c. So when v is very very small, obviously the small value divided by a very big value is going to come almost negligible. That value is going to come very very small, so it is always better to neglect. So when you're neglecting this term in this factor, so only 1 is left. So root of 1 is almost 1. So when you put this value 1 in this equation or maybe in this equation, this indicate that the length of the rod measured in the stationary frame is L and in the moving frame is L dash, that is same. And this is what generally happens in our daily life, because all the motion what we are seeing around us is almost less than the speed of light many times. But suppose when the speed is increases and it almost become a comparable to the c, that is speed of light, that time when v is very greater, c is also large, so this is obviously will come less than 1. So 1 minus less than 1 will be less, the whole quantity will come as a less than 1. And when you put this here, when this quantity is less than 1, so this length which is observed by moving frame will be also less. And therefore a person moving in the frame, when he sees the length of the rod, he will observe the length of the rod is get contracted. Therefore it is coming L is less than L dash.